Hello guys, I am Vinay Pandey, Master Teacher in Vedantu, and let us solve question number 12 of JEE Advanced 2020 Paper 2. And this question number 12 is a multi-correct answer question. It says that consider the following transformations of compound P. Compound P is given, its molecular formula is C9H12, and they are saying that on reduction with platinum hydrogen it gives this carbon, this hydrocarbon, it is a cycloalkane with a side chain of 1 2 3 carbons, right? So that means our P is having this carbon skeleton only, right? And for P there are two options given in option A and option C, which are having the same skeleton, which will have same skeleton after reduction with platinum and hydrogen. So we can consider one out of these two options A and C as the starting compound P. Check करेंगे, we shall check it out. There is the reagent X. When this P is treated with reagent X followed by KMnO4 in acidic medium and heating, we get Q, which is one carbon less. You see, it is one carbon less. That means KMnO4 breaks the multiple bond in such a way that one carbon which is free is out and 8 carbons are intact, maybe part of the ring and side chain, right? And 6 oxygens are introduced. That means 3 COOH groups are formed. Understood? Get the point? Are you getting? So what we shall do, we shall consider P as one of the structures of A or C, and then reagent X is palladium, carbon, quinoline, and H2. That means it is a Lindlar catalyst which will convert triple bond to double bond, and carbon skeleton is given here. P has a carbon skeleton which is given here at this, in the form of this compound. And then we shall go to the left side also once the P is confirmed. So let us consider P as option A first. Okay, if option A you consider P as option A, that means the compound given in option A, then you will see that it is 1 2 3 and this one, right? If we go for Lindlar catalyst, that means H2, palladium and barium sulfate, you will have this compound 1 2 3 and double bond. And when you treat it with hot KMnO4 in presence of H2SO4, then see, this bond will be broken from here and from here, right? So what you get? You get one COOH at this position, right? And one COOH at this position, and one COOH at this position, 1 2 this position, and one CO2 is out, of course. Now you can see that this compound is not optically active because both these two groups are actually identical, right? It is optically inactive. That means our P is not that structure which was given in option A, and A option is not the answer. Okay, so let us consider compound P as the compound given in option C, right? 1 2 3 carbons are there at the side chain. Okay, then we shall treat it with Lindlar's catalyst, right? You will get this compound where triple bond outside the ring becomes double bond, and double bond inside the ring is unaffected by the catalyst, like this. Now if you treat it with KMnO4, guys, if you treat it with KMnO4 in presence of H2SO4 and rather you heat it up, then you will see that this bond is broken and this bond is broken, and you have one COOH here, one COOH here, and 1 2 one COOH here. And now in this case, this carbon is a chiral carbon. You can check, these total number of carbons are 8, 1 2 3 4 5 6 7 8, and one carbon is chiral also. That means this compound is optically active. Okay, so it is confirmed that compound P is the structure which is given in option C, and also we can confirm that option C is the correct answer, right? And even option B is a correct answer because it is a Lindlar catalyst. And you can see if you go towards R left side, then you will find that it is getting started with the compound given in option A, which will be ultimately wrong. But if we shall go to the left side, no problem. We will go to the left side. What is left side? Left side is like this. This is your starting compound, right? This is P, your starting compound. Now you are treating it with NaNH2. NaNH2 will make this, it will take away the acidic hydrogen and will make that carbon an anion like this, CH2 C triple bond C minus Na plus. This is the first compound after treatment with NaNH2. Then we treat it with what? Then we treat it with acetophenone. Okay. So acetophenone means you are treating this compound with acetophenone, right? This compound, this C minus, will behave like a nucleophile and it will attack on electrophile carbon, and you get the product like this. You see, you get the product like this, where this is triple bond. This is not H, I'm sorry. This is triple bond C, and this is CH3 O minus and pH, right? And then you treat it with H3O plus and heat actually. Okay, if you give H plus, then that O minus will become OH, that means alcoholic, and this compound, which is now an alcohol, tertiary alcohol, on heating in presence of H plus, will give E1 reaction and an alkene. So actually you are getting this product in which this double bond will be here and this is the benzene ring. This is actually R, and this R is not given in last option D. Option D has a structure for R which is wrong. That means our answer for this question are B and C options. Understood?